Yep, and then transcript. Okay, great. Good. So, hello everyone. I think people who is outline now hearing us very well. I can see we have like 5 people here in the room, so we can start the lecture today. So actually, the lecture today will be the introduction to the machine learning and the AI in general. And we will introduce it with something related to what we got, which is a clustering of the data that we was working with. Now I think, or I hope that you understand why this introduction came late in the course. It makes sense to have such introduction at the beginning of the course, but now it's in the middle of the course simply because, as you understand now, machine learning is not an advanced stage, things that we should do. But first, we need to collect data, we need to clean the data, we need to represent and see what is in the data. And then we go for machine learning. So actually, machine learning and application of AI is not an advanced stage when you start your PhD or when you start your master work. It's something late. And in general, we can use machine learning or artificial intelligence in 2 ways. The first way is to use it in your work. And I assume all of you are here in order to see how you can apply machine learning into your methodology. If we give this course to people in physics or in mathematics department, it will be different context. In this context will be how to develop a machine learning algorithm, how to develop something from scratch. Okay. But actually what we will present in this course is existing models, complicated models. We will explain how it's complicated. And you will see that when people say machine learning, you will find that it's very easy. It's just one line. Just one line. You need to write a code. I think now after this 8 lecture, you already have good experience how to write codes. I hope you have good experience how to deal with data. So it's just one line. You will add it to your code, and this line will do the machine learning. But the things behind this line is complicated. Okay, so we will try to explain how much is complicated, and then by the end, I will give you this line. And whatever you think about in your work, you will find a line that can make it for you. Okay, so actually, today we will work about this data clustering. Next week, I think we will take this PCA, the principal component analysis. Then when we go to the course a bit more, we will get a few things related to natural language process. Some of you are interested in natural language process, some are not, but you know, we are like mixing groups. There is people who are working with interviews and people who try to do their master using this citizen science. And it's important for them to know how they can use machine learning and artificial intelligence in their work. So we try to cover the need for everyone. Just a very short introduction. This is just to put you in this big umbrella of the course. So the course started with data cleaning. So we got few codes, few lines, how we can look at our data, how we can define or see what is the different variable in our data. If really the number is existing in number variable or it's in string variables, and how we can change from variable to variable, from string to number, or from number to string. how we can clean the data, how we can fill out the missing value, how we can remove a column, sorry? Normalize, for example, as an example, or just remove the column if this column is not so interested. How we can merge columns, how we can merge different databases, things like this. So this is actually the first step when you are starting with your data at master level, PhD level, postdoc, at any research. This is the first step to collect data and to clean this data. Then the next step is to data plotting, and here the aim of the data plotting to look deeply inside the data, see the relation between the different parameters. Which parameter affect which parameter? Okay, and this is very important in things that we will consider later, like today, for example. Then from data plotting, we should go to data insights. Unfortunately, so far, I know that the master student people didn't make any big progress with the data plotting. They had like a seminar this week, I think, or last week, and they used the seminar in order to work on an old task, so they didn't push a bit toward the data plotting, but I hope they can do so soon. And I think data plotting, all of us, we trained it like 2 weeks ago. It's very easy, right? Just you need to import the correct work package, and you use plot, and the plot horizontal, pie plot, scatter, just plot things and start to look at the different variables. And of course, we need the data plotting during all the course. Then data insight is actually, we need to look in more detail, about the data. This can be looking at the statistic of the data, minimum, maximum, average between the different variable. Look in detail into the different figures and table that you produced in order to see the relation. And again, you as a scientist, you are not a machine that just plots things without thinking. You need to plot, you need to think, you need to revisit your data. Why this parameter is like this? Why there is a relation between this parameter and this parameter? Okay, why this relation is not appear in this data set, but it's appear in another data set? Okay, so you need to think about these things. And once you start to get data insight, maybe you need to return back to data plotting. Maybe you need to plot something different in order to see something inside your data. Or you find that you have a parameter that is missing, so you need to return back to data cleaning to add one parameter missing, and so on. So it's not one straightforward method. You just go, everything going well, super duper. If it's not working well, you need to return back and try to find what's missing there and make it. So today, actually, we will focus on data clustering. And data clustering is unsupervised machine learning technique. Okay. And since I said unsupervised machine learning, so I need to introduce you what is the machine learning, what is the supervised machine learning, and what is the unsupervised machine learning. So at the beginning, this is a chart to show you what's the artificial intelligence, what's the machine learning, what's the neural network, and what is the deep learning. Okay. And you can see actually it's very simple. Deep learning is part of neural network, and the neural network is part of the machine learning, and the machine learning is part of the artificial intelligence. Okay. And I don't know if you are aware that the person who got the Nobel Prize this week or last week, actually, who is the person who behind this neural network. So AI, or artificial intelligence, this is a big umbrella, is referred to simulation of human intelligence. So it's called artificial intelligence. So it's intelligence, it's like thinking, like human, but it's artificial, it's by machine. So AI refer to simulation of human intelligence in machines that are programmed to think and perform tasks like human. So actually it's machine, it's codes, something you write in Python, in different language, that able to think, able to analyze data, able to make decision. Okay, and if you can imagine what you wrote so far from the beginning of the course until now, you will be able by the end of the course to create your AI code. You can automate what you wrote. So you can automatic write one big code that include thousands of lines, and this code automatic go to the data, get the data, open the file, analyze the data, get the different parameters, sort the different parameter in another table, plot this table, okay, go through the different cluster analysis as we will see today, do the principal component analysis just in one code. You don't need to do anything. What we do so far is just you are making it step by step, right? But you will be able to just join all the steps together in one code and just run. It automatically will run everything, and then by the end it will give you a full report to analyze your data without even thinking about what is there. This is a machine learning. This is AI. This is artificial intelligence. In order to do so, you need to understand the smallest step. And the smallest step is how to open the file, how to analyze the data, how to plot the data. And this is what we learned so far in the course. Okay? So AI, it's involved creating computer system. So now you start to create not a full computer system, but you created some code, some lines. And this lines actually is a small codes in a bigger vision. That can reasons, learn from experience, understand natural language, can understand the environment, make decision based on the available data. And of course, the AI, as you see, it's encompass a wide range of technique that replicate the human-like thinking. So this is a big umbrella. This is the AI in general. And now I assume you have the basics to do it. Once you open your Python code, you can understand how to write few lines, you can do it. What you need to do just to make this a big AI umbrella thing is to link these small codes with logic. Like, for example, test this column, okay? And then if this column doesn't include the right variable or include, for example, missing value, make like some statistic around the different value in the column, and then replace this missing value with zero, with average, with median. Okay, you can write this code and then you leave it to the machine, and the machine can run it automatically without testing it. Okay. Then we go to the smaller part, which is this part, the machine learning part. So machine learning, actually, it's something we are doing in order to teach the machine, in order to teach the computer. We teach the computer, or we teach the algorithms that you wrote, the code that you wrote about something. So machine learning actually is a subset of the AI that focus on enable machine to learn from data. and this is most important things, that we can't do machine learning without data. So if you would like to develop a machine learning that will be able to analyze, for example, your problem, your energy problem, okay, or the data that you will collect in your lab in the chemistry, or data you are working with in your master, okay, before you start to develop this machine learning, you need to have data to develop this machine learning. Okay, and the machine learning is very simple. You create a code. First of all, you clean data, you get data, clean it, and then you give it to your machine learning code, and the machine learning code start to understand the pattern in the data. Okay, once it understands the pattern of the data, they can predict what will happen in the next. So, for example, our colleague here work with energy sector in Sanya, right? Not you. Okay, there is one student here. He work with energy sector. Yeah, maybe Shemin. Yeah, maybe work with the energy sector in Sanya, and he tried to predict when the energy will cut down. Okay, it's very simple. He need to collect data over some time, whereas there is like current and then cut down, current and then cut down, and then they will feed this data to his code, and then the code will discover, okay, before cutting down, 1 minute before cutting down, for example, there is one parameter will change, and this is a parameter that causes this cutting down. So what you need, just to give this data in a way to the machine, and then the machine, okay, the parameter is now signing up. This means that the electricity will cut down in 1 minute. And then you can automate the process, and then a generator can work in order not to cut the electricity. So the electricity in the general grid will cut down, but you have like internal generators that can run in order to keep the electricity working. Okay, so actually the code of the machine learning is just looking for this signal in your data. And once this is signal, it will give you a sign, okay, there is something will happen here. And then you can train it as you like. You can train it if, for example, you work in the chemistry that, okay, once I see this sign, this means this product will be produced. Or in sustainability, or in any field. So instead of following strict rules, machine learning algorithms use data to learn pattern and make prediction or decision. So we able to make like decision based on the machine learning. Machine learning algorithms are trained on labeled data. Okay, and through a process called training, they adjust their parameter to make accurate prediction on new unseen data. Okay, so now we go to what's called labeled data. But before we go to what's the label and unlabeled data, one good example of the machine learning is this Tesla car that Elon Musk just announced 2 days ago. It's full automated car. So it just sensor, collect data, and feed it to a computer in the car, and then the car make decision based on the data that is collected. Okay, so what's the meaning of labeled data sets and unlabeled data sets? So actually we can do different type of machine learning. The two famous type of machine learning is supervised machine learning and unsupervised machine learning. The supervised machine learning, you are putting the data with a label. So actually you are forcing your code or your machine learning to see here this data mean, for example, if we return back to to this electricity example. So you get the voltage, for example, and this voltage is indicate voltage when electricity is on. So you write all the parameters, the voltage, the ampere, the resistance, everything related to what you are working with. And then you have a column at the end in your table, in your data frame. And this table say electricity is on. Okay. The second row, electricity is on. The third row, electricity is on. And then there is one column on one row where is electricity is off. Okay, and then electricity is on. So actually you are on and off here. This is the label. So you tell the machine, take care, these parameters mean the electricity is okay. This parameter mean the electricity is off. This is what's called supervised machine learning. Okay.
What does the supervision cover? That it's only yes and no kind of decision.
So it can be yes or no. It can be classification, for example. So, for example, I will share with you a file that maybe Victoria will use during her workshop in the GIS. And this sheet includes 3,000 data points. And for each data, it's include rock type. So actually the label is not yes and no. It can be a name. Like, for example, information, and then the label will be a lady, young lady. Same information, old man. Different information, young man. Another information, children. So this feature is features that characterize a children or characterize a young woman or old woman or young man. And then you feed all of this into your code, and the code start to use, okay, I know this feature is for that. And they start to extract the different parameters or the different feature that can characterize this person or this rock type or this case. Got it? So this is the label, or this is the supervised machine learning. The unsupervised machine learning, you just give the data as it is to the code, okay, without telling the code this is a man or woman or electricity on or electricity off. And then the code will define the pattern and will come to you and will say, yep, this is something here and this is something here. And today we will do something like this. Okay. So this is the two big end member of the machine learning, the supervised and unsupervised. Any questions so far? Good. Any question online from Lean, from Shimon or Victor? If there is anything, just write in chat or raise your hand. Okay, no. Then we go to the Nobel Prize, the neural network. Neural network actually is something as our brain. It's scientists start to work, okay, we need to think and try to convert the machine into a brain, a real brain. Okay. So neural network are a class of algorithms inspired by structure and function of human brain. They consist of interconnected artificial neurons organized in layer. Each neurons take input, process it, use something called activation function, and they produce output that feed into another layer, and so on. So it's very simple. Very simple. So actually the code is include points. Okay, and then maybe another code or another layer, and the third layer, and this is what's called neural network. Okay, and then you get just input. This input can be, for example, an image. Okay, and this is how this Mumbinger, for example, is working. This camera everywhere that gets the number of your car and charge you. It's working like this. So it gives you a picture, and this picture actually go to each point. Okay, and each point analyze something in the picture, just one pixel in the picture, and give you a parameter. For example, say this one is check the first letter, the N. If this is N, this means it's Norway. If it's B, maybe it's Poland or another country. Okay, and then based on that, it gives you a value. So here we have value 1, value 2, value 3, value 4. And then this value goes to the next network like this. And this value go like this to be analyzed further. And this value as well. And this one will give you more information, more data, because it's go a bit deeper to analyze in a bit deeper level. And then the value here goes to this one, this one, this one. The value here goes to this one, and this one, and so on. And by the end, the summation of all of these things that is coming from the last layer will say this car has number of N blah, blah, blah. It's car for Mushtaq, for example, or the car of Ken. Okay, so this is how the neural network is working.
Does each point contain the same analysis?
No, it's different analysis. And it's different from network to another network. So if you are doing analysis, for example, to analyze photo, it's different than the analysis to analyze text, for example. You can use the same structure to analyze text or to analyze YouTube video or to analyze. So for example, YouTube videos, when they start to test if the audio, for example, in the video is stolen from somewhere or not, they're using the same way. They just get the audio and then they feed into a neural network, and then they start to define the pattern in the audio. And they can say, this is just stolen from this music or from this movie. Good? Great. Anyone can give me a feedback what is the deep learning is? So this is the neural network. What is the deep learning? Anyone can expect it or suggest something?
It is the same principle of feeding labeled data to a neural network. Then expecting this network to come up with a new result. So,
but this is a normal network, right?
So we expect it to be able to analyze such data that we haven't fed in before after the learning process.
But again, this is a normal one. Because actually, when we start to develop this machine learning or this type of network, you normally didn't feed all the data to your model. You just feed the training part to the model. And then you use like 1/3 of the data to test the model. Okay. But anyway, you would create a model in order to work as a standalone model. Like, it should work with data that they are not trained on it. Any suggestion what the deep learning is? People online, any suggestion? Well, if we say the normal network is include 4 layers, for example, the deep learning will include 10 layers, just 1 layer more or 2 layers more. So actually the deep learning is exactly the same like neural network, but we add more layer. And this means that they analyze the problem with a bit deeper structure. Yeah. So this is a normal network. Like we have an input data, and then we have different network, or we have different layer, and in each layer we analyze something, question, we analyze part of our problem, and then it feed up to the next layer and feed up to the next layer and so on until we got an input output that say this data is such type of data. Okay. The deep learning is the same structure, but it's a bit complicated. Like, add more layer, add more points to analyze the problem. Okay, so we can read this together. Deep learning is a subfield of machine learning that use artificial network, neural network with multiple layer. This is why it's called deep. It's deep neural network to model and solve complex problem. The term deep refers to the depth of the network, which mean having several layers. So it's normal network, but it has just several layers. Deep learning has gained significant attention and success in recent years due to its ability to automatically learn pattern and hierarchies in data without the need of manual feature engineering. So deep learning can do it without feature engineering, which is supervised learning. So you can just give the data and they can understand what is going there.
Correlation, not causation problem.
What you mean?
Because if you have some correlation, but they are just by chance, kind of.
Yep.
I have a blue sweater and the sky is blue. Does deep learning somehow deal with that problem, or is it easy to kind of get confused?
No, I think if the data is very clean, because you will not say that I only have 1 point, like I have blue t-shirt and the sky has a blue color. Okay. When you train this model, you give a lot of data. So your t-shirt, got a shirt, my t-shirt, right? And definitely not all of our t-shirts has the same color as the blue. Right? So they will discover, okay, this is just coincidence, like, the color here is like the sky things. Okay. But this doesn't mean that they are very super intelligent. Again, we return back to the first lecture in our course, that if you train your data with shit data, you will get just shit model. So if someone fabricate data and they say, okay, there is a correlation between the shirt colors in this room and the sky color, for example, or the temperature, okay, the model will say, yeah, I see correlation. right? So on the quality of the data that you are feeding your model with. And this is why we spend 7 lectures in our course just to clean up the data, because this is the most important things. If you feed the data or the model with data that is just rubbish, you will not get anything. But so this is a few things you can read at home, like the scope. You can read together. So AI is a broad field encompass the study of creating intelligent machine and systems that can mimic human-like intelligence. Machine learning is a specific subset of AI that focus on enable machine to learn from data and improve their performance without any programming. Neural network is a part of the machine learning, is algorithm inspired by the structure of the human brain, used to model complex relation in data and solve various problems. Deep learning is a subfield of machine learning that use deep neural network with multiple layers for high-level representation learning. So just summarize what we said before. Okay, go on. This is a different learning approach. You can read this, but AI can include rule-based system, expert system, symbolic reasoning, learning-based approach like machine learning and deep learning. It can be like normal codes. Just if you succeeded to train the machine to do something, even use this if sentence, like if you find this pattern, do that such thing. It's AI. Machine learning uses data to learn pattern and make prediction, while the learning process is more mature and traditional AI methods. Neural network and deep learning involve learning hierarchy representation from data, making them especially effective for complex tasks like image and species recognition. Okay, this is just a few things about the network structure or neural network structure. Neural network consists of interconnected artificial neurons arranged in layer. Deep learning is the same neural network, but it's just multiple layer. Good. So we can have this, and then we can stop for a break and then return back to the clustering. The natural language process. So I think all of us now know what the natural language process. Like ChatGPT, for example, it's natural language process. And actually, natural language process is like it's mixing between AI, machine learning, and deep learning. It's take from everything, and it's new field about natural language. So natural language is a specific branch of AI, so it's part of AI that deal with the interaction between computer and the human language. So actually they can understand human. It involves technique and algorithm to process, analyze, understanding, and generate natural language. A natural language process encompasses various tasks such as text classification, classify the text, sentiment analysis, so they can understand the context. So if you give them a paragraph, they can understand what is behind this paragraph. They can translate things from language to language, like Google, for example. Google is actually a natural language process. They can make a summary. They can identify language, so you can speak and they can identify what you are speaking on. They can generate language, they can generate text, they can do anything with language, as for example, the ChatGPT. Okay, but of course the complication is based on, like ChatGPT is big company that are supported with billions of euro or billions of dollars, and they have supercomputer, they have hundreds of this neural network to analyze the text and understand what is behind it. you can create something like ChatGPT using this very Python thing, this simple thing. But it will be a very simple that analyze some paragraphs. But they are not able to learn from a lot of text because you need resources. But you can create this, no problem. Good. So this is just a quick overview about the artificial intelligence, machine learning, network, and the natural language process. And then the next step after the break, we will go to this data clustering, which is a technique, unsupervised technique of dealing with the data. Okay, so now we will return back to what we are doing with our data. We give you an example, and then we will see how this example will work. Great. Great. So maybe a break. So far you see the course is interesting, or?
Yes.
I think the fun part will start today. Good. So maybe, okay, we can wait a minute. Okay, no, just go. Sorry, people online, we just wait for a minute or so because there is two colleagues who are outside. Just waiting for them. Okay, so maybe we can start until Kata is coming back. So now we will have a real example of the machine learning. And this is unsupervised machine learning. And we will use it as extension of what we are doing in previous lecture. Like we already have data, we clean the data, and then we started to work on this data. So actually the coming part, we can split it into 3 parts, like the logic and the why you are doing that. Second, the methods behind this. And then finally, this one line that does this work for us. Okay. So all of you are researchers. Some of you are already advanced. We just started. Okay. And my question is why data clustering is important for you, for your research. We just started Kata, and I try to ask them as a researcher why data clustering is important for you. Okay, this is just the logic behind what we are doing here. Why? Any thoughts?
Investigate the differences between populations.
To investigate different into population, yeah. So we speak about population here, data population, or can be like ecosystem, like animals, or yeah, yes.
Maybe to investigate how the different parameters are affecting different groups.
Okay, how different parameters can affect the different groups, yes. What else? Maybe one step before you, yeah, please, Mushtaq.
Is the first.
Exactly. Yes. So actually you said how different parameter can affect the different group, but we don't have group yet, right? So we need to see the different group. And then after that, we will see how the different parameter can affect the different group. So actually today, we will see how we can understand how many group in our data, how many population in our data, how many animal in our ecosystem, for example. Okay, this is today. Next lecture is to see how the different parameter affect this different groups. This is the principal component analysis. Okay, but as a first things we need to know how many group we have, right? It doesn't make sense in order to do a research. It doesn't make sense that you make an experiment and you study, for example, Mushtaq, he is a chemistry person and he tried to develop, I don't know, you are organic or inorganic? DNA, inorganic, okay. Yeah, okay, chemistry animal. So it's not possible to start, for example, to do a big analysis only in one DNA. Maybe, I don't know, but only in one analysis, right? You need to have 100 of analysis, for example. You need to have 100 of observation, data points. These data points, it can be related to one animal, okay? It can be related to different animals. It can be related to, for example, if we get this example about this cutting energy and coming energy, it can be related to cutting energy or energy is on. So we have two different events, but it doesn't make sense to be related only to one event. Normally you have more than one event. Normally you have more than one animal in your ecosystem to understand how this animal affect on that animal, for example, right? So normally you have 2 or more, right? Good. So this means that you have a lot of data you will collect, and you need to see how many group of the data that you have. And based on that, you start to look, okay, I can see in my 1,000 analysis, I can see 2 trends, one positive and one negative, for example. Or for example, in this case, I can see in my bots, there is some bots buoyant that is between 8, 7, 30 to 10, some other between 2 to 6, and some is a bit different, which is in the y-axis between 3 to 7. I don't know what this data about, right? But I can see there is pattern. I can see there is group there. Okay. When you collect the data in the lab or in your master thesis or your PhD thesis, actually you collect it without color. So when you print it or when you plot it using Matplot, for example, in Python, you will get all of them with green color. But we need to distinguish them. And this is a clustering. So the clustering is a way in order to distinguish the different group in your data. Okay. So clustering is a technique for finding similarity groups in data. It's called the cluster. It groups data into instances that are similar to near each other. So actually, all the green is near to each other. All the red is near to each other. All the blue here is near to each other. That are very different from far away cluster. Clustering is unsupervised machine learning. It's unsupervised. So actually, when we start to cluster, you don't know which group, right? You just give the data and the machine automatic give you, okay, this data group 1, group 2, group 3. So you didn't say this is group 1, this is group 2, and this is group 3. The machine creates this for you. It's unsupervised. A very simple example. If we have such what's called in English, I don't know, but if we have such tools that you can use to close the door, and then it's just random distribution, then if you run this machine learning, this clustering, it will give you, okay, we have 2 yellow, 1 small, 1 big, and 1 green. So we have 3 groups. It's automatic understand what is in the group. There's just some blah, blah, blah. You can read why clustering is important. Of course, it's blah, 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 but it's important because this is the exam. Because I told you we have like at each lecture, we have blah, blah, blah at the beginning, and we have the practical part at the end. So the blah, blah, blah at the beginning, this is the exam. So this is the exam. So for example, data, we can use clustering in data summarization. Clustering help in summarizing large data sets by grouping similar things. So instead of understanding or studying 1,000 points, you can just describe 3 groups, right? Because in your thesis, when you start to write your thesis, you need to write a data description to describe your data. And it's impossible to describe 1,000 points. No way, right? But you can describe through groups. So if you describe or you group your data into 3 parts, 4 parts, 5 parts, you can describe this in detail. It can help to better recognition. It can help in detect anomaly. So like one group is very high, one group is very low, one group has a lot of carbon dioxide, for example. One group is an animal that infected by something. Okay. It's very helpful for data pre-processing. So actually, now we take this part as a part after data processing. So we already cleaned up the data and we make it clean and everything is clean now. And we now trying to do cluster. But we can do that and then we return back to do data processing. So if we say, for example, there is one group that is give like very negative anomalies, something that is we don't want anymore in our data, right? So we need to return back to see why this group gives this anomaly. Is this correct numbers or not? Okay. For example, customer segmentation. This is like business things. Like assume that you are opening a restaurant here in Tromsø, and you have some data from people around Tromsø who are visiting restaurants, and you need to understand the behavior of the people. So you can collect this data, and then you can analyze them, you can segment them into groups, and you can say, my restaurant is middle-class restaurant, so my target is this group. So I need to do good things just to attract these people. So it can be customer segmentation, it can use as you like. It uses an image and signal process, so you can cluster the pixels, and you can say, yeah, this pixel is dark, this pixel is red, this pixel has this color or has this feature. It can be used to recommender systems, like to identify the similarity in different groups. It can be used in spatial analysis and GIS. It can be used in dimension reduction, and this is we will use it in next week. So next week will be mainly about dimension reduction. Of course, it can be used in decision making. So we already understand we have 3 groups. This group of people has a crime behavior, for example. So we need to investigate them in more detail because they are doing crime or their behavior is not good, right? So it can be used in as you like. Just why? Very simple. Simplification. From 1000 points, you can make only 3 groups. Pattern detection. It can give you like a signal in the pattern. Some group is high in silicon, some group is low in this parameter. Useful in data concept and construction. Once you see the different group, you can see, this group has this parameter, this group has different parameter. So you can understand the relation easy. Of course, it's unsupervised learning process, as we will see in a few minutes. Where we can use it? Everywhere. Data mining, informative retrieval, text mining, web analysis, marketing, medical, in your master thesis, in your PhD, in your postdoc, everywhere. There is no science without clustering. So you need to do clustering first in order to understand your data before you start the interpretation. What's the different type of clustering? We have several types of clustering. Actually, today we are focusing on this k-mean, but we will explain this hierarchy algorithm as well. So we will explain the hierarchy algorithm, and then we will go a bit deeper in this k-mean algorithm. So we have 2 ways. We have what's called hierarchy algorithm, and this is actually 2 ways, bottom up and top down. It's very simple. Bottom up, you start to use analysis by analysis. Okay, and you say, okay, Kata, for example, is a lady. So we will put here in group lady. Okay. Your name is not Lynn. Matta. Matta is lady. Okay, so we will put here in a group lady. Okay, Mushtaq is a man, so he's in another group, and so on. So we go from bottom to up. We can go from up to down. Like, for example, in this room, we have 6 persons. Okay, and this 6 person, it can be in 2 groups, man and woman. And then we start from this level, we go a bit down until we classify each one in the room. This is man, this is. Okay, this is the hierarchy, either from bottom up or top down.
Example, when we enter a metadata document, and then it describes how many data points we have, and some of them are, I don't know, under 100, and the others are float numbers, and it announces these groups within the data, and then we enter the file, and then we see each data point.
Yes, it can be like this at this level. So you can use this cluster in order to analyze the metadata in your file, or you can use it to analyze the data itself. So again, it can be used in different meaning, different way. Okay, you have question? Okay. Then we have something called partitional clustering. And here we are using something called k-means, or the example of this partitional clustering is k-means. And k-means actually is, we can say it's a space clustering. We cluster based on the distance between the points. Okay. We will come now to the k-mean. But first, just to show you this hierarchy structure. So it can be like this from top level to down. I can see two groups here, man and woman. And then in the man, I can see three group, four group. Okay. And then from this, we start to go a bit in order to see the different cluster. And then in the woman as well, I can see two group in the woman because we have only two ladies today. So only two group and so on. Or we can build it from bottom to up. This is a partitional clustering. We plot the data using feature 1 and feature 2, just two features. It can be more than two features. And based on this feature, the data is plotted. And then we start to say, this is nearby to each other. So this is a group. And this is a second group. And this is a third. And this is what we will explain it in the coming 30 minutes. Okay. How we are doing that? By a method called k-means method. The k-mean method, actually, it's cluster based on number of the clusters. So actually, we give, or we think at the beginning, we have a certain type of data. And please be concentrate with me because now we need your contribution. And the first thing I will do is I will assume how many clusters I have. I will say for this 1,000 data, I have only two clusters. Just assumption. Okay. And then I will start to calculate the distance between each point and the center of this cluster. Okay. And then based on that, I will see if really I have two clusters. So I can give you an example. So assume that we have data and we have feature 1, feature 2. This is the feature that we will use for clustering. And then this data is here. Okay. Something like this. It's not really, but maybe I can. Okay. So the first thing I need to assume how many clusters. I would say, for example, I have only two clusters. Okay. So I will put these two clusters, the center of these two clusters, just randomly. So I will assume that I have a cluster here, 4 here, and another one. Just a random one. And then I start to calculate the distance between each point in all of these things to this cluster. And then I will calculate all the distance between all of these points to this cluster. Okay. How we calculate it? Simple, because we have F1, F2, This is like a triangular. And then when we calculate this distance, actually this distance is equal to the second root of this is y square plus x square. So we calculate this square, and then we get the root. This is our distance because it's 2 dimensions. Okay? And based on the numbers that we have, we will say, really, we have 2 clusters or not. Then, it's not working. It's not 2 clusters. Maybe it's 3 clusters. Okay? And then we start to put 1 cluster more.
If we assume the right amount of clusters.
Here, it's visual and assumption. So you see here, I think here there is group. So maybe there is 1 cluster here, another group, second cluster, maybe here, 1 cluster, 3 groups. And then we start to put, okay, I will put cluster here, cluster somewhere here, and the cluster somewhere here, and start to work. Just visual, because we are doing it by ourselves, not by the machine. There is method, of course, for that. Okay, but this is how it works. So this is the mathematics behind it. So the mathematics behind it, we assume numbers or clusters or points in our space. And then the point is the sum of the distance around this point should be minimum. So minimum, the minimum. So if we assume we will take only 1 cluster, just 1 cluster. Okay, and we add this cluster and we start to calculate the distance. So it makes sense. This distance plus this plus this plus this plus this, it's minimum, right? But once we start to add such point, which is far away from this point, the distance will start to increase, right? So 1 point is not enough in this case because the distance start to be big, large, right? So maybe you can add another point. Okay, add another here. And then start to calculate the distance. This cluster or this point will give us minimum. And this point will give us the minimum. Okay, so I understand this is group, this is group. And then here, when we start to add this group here to this point, the distance will be increased too much. And when we start to add this group to this one, the distance will start to increase too much. So it doesn't work. Maybe we can add another cluster here. And then we start to calculate the distance from here to around. Make sense? Makes sense. Doesn't make sense? Maybe we can add another one and so on. So we add points in order to keep the distance between the center of these points and the nearby data points to them.
Do we add only 1 distance to each point, so we don't calculate all the distances to all the clusters?
No, you should calculate all the distance. But for example, you say the distance from this point to this point, say 2 units. And the distance from this point to this point is 1 point, is 1 unit. So this point actually should be here, because the distance here is short. So you all the time go to the short distance between the point and the center of the cluster. Okay, makes sense? Makes sense. But we have a problem. A simple problem. How many points we have? I can add for thousand data point, I can add 1,000 cluster.
Isn't it the case that the more points we add, the more distances we will have? So it will again.
No, actually, when you are calculating it, you are calculating it in two ways. You add the point, and then you calculate all the distance to all the points, and then you add another point, and you calculate all the distance, and then if you see, okay, it can work with 2 points, you start to calculate all the distance around this point, and all the distance just around this point, and so on. So, for example, you add 1 point, and then you calculate the distance to all the points and say the sum, for example, will be 20. 20 units, the summation of the length between all the point and this one. I will add another point, and I will start to calculate, but here I will split our data somewhere here. And I will calculate this, and I will calculate that. So this one will give me, for example, 10, and then this one will give me 5. So now the total will be 15. It's less than 20. Then I will add 1 point more here and start to make sum, and the total will be 12. Okay, and then I will add a point here, for example, a new cluster, and then the total will be 10. The total of the distance to this point will be 10.
If we partition the points again.
Yes.
So we always draw up a new line from which we calculate distances.
Yes, and then you calculate all the distance again. You draw a new line here, for example, we add here a new point here, and then we say, okay, this point can be this. Then calculate the distance here, and then calculate the distance here, and there. So, make sense?
After those lines.
Well, in your case, you will make it visually, but in the computer case, it will be automatic. Well, I think this is a good question because we need this. Now, what we did, we try to know how many clusters we have. Because the problem here in this clustering, we don't know exactly how many clusters we have. And later we will see that we will move the cluster. Like we will assume our cluster is here, but we will move it to be here or there in order to reduce the distance. It will be the same cluster, but we will move it. But at least we assume we have 1 cluster. We assume we have 2 clusters, 3 clusters. How we know this number? So how we know this number? It's exactly what I said, like you assume 1 cluster. Now I will draw it. So here, this is the clusters. And here, the total distance. And I will start with 1 cluster. So cluster 1. And this cluster 1 give me very large distance, say 25. Okay, so 25. Cluster 2. Now we have 2 clusters, so the distance will be split in 2 clusters. Give me a number, just rough number. say 20. So 2 will be 20. We will add one cluster more, 3 clusters. Now the distance will be split over 3 clusters. How much is the total? Rough number, in a rough number. Then 17, make it 17. So 17, okay? Then we will add cluster number 4. 15, okay? Now 15. Then cluster number 5. How?
12.
12. Cluster number 6. So we add a point and then we just measure the distance around this point. The total distance for all the clusters. How much? 6? 5 is like this. 4 is 7. 3 is like this. 6. Maybe 10. 7. 8. So 6 is 10. 7 is 8. Try to link. Will be a bit stable. The number of the clusters is this. In our case will be 7. When our curve will take like this from steep to a bit flat. This is the number. Number of the clusters that represent the system. We can go for 20 clusters, but it will be more detailed. We can go for 1,000 clusters. Each cluster around 1 point. It's 1,000 clusters. It's correct, but doesn't make sense. We need to reduce the number of the clusters, but reduce it in a meaningful way. Right? So the best way is the cluster where this curve is bent from steep to a bit flat. In our case here is 7 or 6, 7, 6. Okay. You have a question?
In every case, when we are trying to cluster matrix, there will be this inflection point.
Yes.
When the steepness changes in every case.
In every case. Yes, in every case. And this method is called ALPO.
But if there are no clusters, can it be that there are no inflection points either?
Well, if you don't have clusters, this means that your data is random, has no relation to each other, so there is no science. So there is no point to do anything after that.
But let's say that we can't say in advance whether our data has clusters or not. We want to determine it by an algorithm. And then we just put this algorithm onto our data, and then we won't find any inflection points. And that's
no, you have to find an inflection point, because simply when you start to increase the number of the clusters, the distance will be a bit stable. It's similar, smaller. Like you will, once you put 2 points, you will, the distance will drop from 20 to 17 or to 15. 3, the distance will drop again, but not too much. 4 will drop, but not too much. Once you reach to the maximum limit of the cluster, the distance will drop, but not really much. So you can really see the slope in the line.
It just bothers me that it's not every data set that has clusters. Some data sets can be random, but you might not know.
Again, if you have random database, there is no clusters. This means there is no relation between your data. Okay, and this means that it's not data, it's just random things.
That means it's one cluster.
In this case, it will be one cluster, which is random data. But normally, if you have data, you have to find clusters in the data. And this is what we are doing. This is the science rule, to have data and start to look into the data and try to find this, how many clusters, and then what's the relation between these different clusters. Okay, questions online, people online. I think Kada is not convinced yet. Yeah, but we can go. We will leave this mathematics things. Okay, this is a sum. This is the equation that calculates the sum. Okay, this is how we calculate the sum, the distance between 2 points, just to get the sum. Okay, and then of course k should be a positive value, and it should be less than n. N is the number of the points. It's not make sense to have 1,000 points and then we have 1,000 cluster. What's the point of that? Okay, this is just an example to show you what's before and after. I need to just run a bit in order to show you this ALBO methods, because you already gave us this feedback. Like, this is the data distributed randomly, and then this is the data after the k-mean. We can see that we have here in this data 3 clusters. We can return to this, how we are doing that. Or maybe we can say, like, this is how the computer program do it. Data. This is how the computer program. You assume centroid, which is one cluster. And then it start to calculate the distance between all the objects to this cluster. And then group the distance and see how many the total distance. It was 20 or 25. Then add another cluster and calculate. And then see the distance. Small, okay. Again, round until we get the correct number. Okay. For each round, we calculate this total distance. Good. And then we make this ALBO figure. So actually this figure is that figure, this curve. And this is actually, you calculate this by yourself. So we assume one cluster. The total distance here is 2. 2 cluster. The total distance is 0.9. 3 clusters, 0.7. 4 cluster, 0.5 something. 0.4 something. 4 something. 4 something. So once we start to increase the cluster, the curve will be from very steep to a bit shallow. And our cluster, the number of the clusters that represents the system, is actually when the curve is bending. In our case, it should be 4, 5, or 2. Sorry, 3, 4, or 2. So this, that, or that. But at least we have 3 numbers. And then we start with 3, which is in middle, and start to do our analysis and see if we really 3 cluster is enough, or we need to go 4, or we need to reduce it to 2. So it's one of these 3 numbers, because the curve is bending around this number. Okay, and this is called the ALBO method. This is how we calculate the how many cluster we have in our system. Okay, convinced? Not yet. Okay, we can discuss this later. Okay, and of course this is a very complicated equation, but this is a sum. This is exactly what we did. We tried to calculate the sum from the point to our center, and then calculate all the sum from all the clusters, and see the total, and then increase one cluster more, and so on. Great. I think we have only 10 minutes. Okay, we came to the code. This is good. Now I need before we come to the code, what is happening after that? We know that we have only 3 clusters. The code, what is doing? We just assume the 3 clusters somewhere. Okay, so our 3 clusters will be, for example, here, one here, one here, one here. And then again, this will not give us the maximum or the minimum number. So we'll start to move this point to the center. Move this point to here. Move this point to here. So actually the logarithm automatically start to move the points in order to minimize the summation. Because we know already we have only 3 clusters. So we play with this 3 clusters in order to minimize our sum. Good. So the question now is, will you do this in your master thesis? So will you, when you start to deal with your data, your chemistry data or your data, will you do this process and assume points and move the points and manually? Yeah. Yes, it's not make sense actually. Maybe old people, like 50 years ago or so, they can do it manually, or actually not manually but visually, like plot the data and make the cluster based on the visualization. But now you don't need to do that. It's just code, easy peasy. Okay, so if we start this code, actually this one is sklearn cluster. This package, this is the first time to use this package in our work. This is the package where you find all the machine learning algorithms there. And from this package, we will download cluster. And from this cluster, we import the k-means. So you don't need to do all of this. There is already someone who spent hours to measure this distance for you and write a code for you. And this code is called k-means. Okay? And then, of course, here we try to plot the graph. And then we, first of all, try to download the data. Of course, we need data in order to do this clustering. And then here we have this in Reader. This is actually to draw this graph. Okay, so we calculate like a data frame. In this data frame, you see, I start to work with cluster from 1 to 12. And for each cluster, I start to get the k-mean, and I start to calculate how many the distance between the points to cluster 1, and save the number in this data frame. And then 2 clusters, save the number in this data frame. 3 clusters, 4 clusters, until 12 clusters. And then I will plot the figure, which will give me this shape. And based on that, I will see how many clusters. Okay. No, just based on summation. I I can imagine I have something around 5 cluster, 6 cluster in my data. So why not? I will try to see, I will test from 1 to 12. If you have a very large database, from 1 to 20, from 1 to 100, doesn't matter. By the end, it will give you this graph, and then you choose whatever you want. Just to draw this graph for you. Okay? So here there is no assumption. You didn't say I have 3 clusters in my work. You say I have clusters, but I don't know how many. It should be between 1 to 12. So I say, okay, work from 1 to 12, or from 1 to 20, or from 1 to 100. Or if your data is 1,000, data from 1 to 1,000. Okay? You are not convinced yet. So actually, this thing is just to draw this figure, not this figure. The figure down, just to see how many cluster we have.
In this code, it's us who decides the assumed number of clusters.
No? You
The 1 to
didn't,
12.
you didn't, yeah, you said just it's from 1 to 12.
That's what I decide to write here. If I
Yes.
decide that, well, I don't think I have more clusters than three, then I just write 1 to 3.
Yeah.
And I might be wrong.
Yeah, and this is why we increase the number. I know here in this code, we have like 3 or 4 clusters, but I wrote from 1 to 12. So I just to see the awful figure. So I know in my data, in your data, you have the data here at 4. But in order to see if your assumption is correct or not, you make it until 12, just to see this elbow shape. Or until 20, or until 100, doesn't matter.
So it can happen that, for example, I write this 1 to 12 number,
Yes,
and then I see a constant decrease. And I see that, okay, I still need to increase the graph
increase it.
by the
Yes.
point.
Yes.
Okay.
And this is just like this. Like, you don't need to spend hours to calculate. So if you are not happy with 1 to 12, and you find this steep curve still as a steep, increase it to 1 to 50. Okay.
And then when I find the right number,
Well,
the alpha.
now we found the right number. This figure, just to plot, show figure. So actually, this is just to plot this elbow segments. So it's just figure. Here, I already defined that we have only 4 clusters. So here I start to see how many clusters to draw this. So based on that figure, we saw that we have only 4 clusters. So here I start to put a curve. Now calculate my key mean, and I know that we have 4 clusters because the previous figure gave me 4 clusters. Okay, and then draw some X and Y just to visualize the 4 clusters. Good. I think we finished, but we didn't run the code. I hope that you can give me like 5 minutes just to run the code, just to see. Okay, first of all, just to see the data. This is our data. This is social science data. It's not numerical data. It's social science data. It's vision around how we can use our ocean. Okay, it's different vision from government, from people, from organization, from publication. It's around 1,200 vision around. So it's if we go from here down, it's real big data, like I think 1,000 something. Okay, and then in each vision we have different parameter. We have species, we have ecosystem, we have biodiversity, we have sustainability, we have natural contribution, lifestyle. And you can see here we used 1 and 0. 1, this means this vision considers the species. 0, this means this vision doesn't consider species. So it's like something about energy, about something that has nothing to do with biodiversity. Here, for example, this vision consider ecosystem. This one, no, it's not considering ecosystem. This one, actually, doesn't consider the natural consumption for the people. This one consider it. So it just some parameters, and then we measure this parameter in each vision, and we say it's 1 and 2 and 3 and so on. And actually, this number is both based on natural language process. So we have a code before in order to clean the data and try to see if we have this vision there or not. If we have this parameter there or not. And then we automatically code a code, okay, if you have this parameter, put it 1. If you haven't, put it 0. For all the visions, for all the text. So this is not one day work. It's a big process for data cleaning. We extract the text, we feed it to natural language process, and then we start to train the model based on this different parameter. And we say, if you read this parameter, put 1. If you didn't read it, put 0. If you find it, put 1. If you didn't find it, put 0, and so on.
Was the text scientific papers?
Scientific papers, websites, government points, reports, everything. Different ideas, just to see how many vision around the ocean things that take care of the ocean, and how we classify them, how we can cluster them. One vision is one text. Okay, but anyway, we ended with this table. This is data. This is 1,000 points, and we need to cluster them. Okay, so we wrote this this code. I think it's too small to see here, but anyway, you know, we imported the file, blah 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 blah, and here we run this intra things. Okay, and here we test how many cluster we have in this big file from 1 to 2 to 12. Okay, I will run this. Of course, it will give us all the codes, but doesn't matter because actually it should finish here just to see the figure. But no problem, we can run everything. Good, we have a lot of error. Permission denied because simply I opened the file. Okay, sorry, close the file. Now it should work. So actually this is calculate these things. You see it takes some time. Our help. And this is our vision. We can do that. Just to minimize this. This is an important thing for now. This is our help. And you can see our figure until 12. 1, 2, 3 until 12, right? Let me try, for example, Kata, for example, didn't like 12. I don't know why, but say I assume my clusters is 25. Okay, so I will increase this number from 1 to 12. I will make it to 50. And I will see if this will change the story or not. Run. So what is doing now, the program is try to put number, calculate the distance, a number, calculate the distance, and so on. It's do it for us automatic. Of course, it takes some time because now the number of the cluster is 50, so it's more. I think there is a problem here. Yes. Yes, but there is a problem in my code. The problem simply that you see here, the x-axis from 0 to 11. So actually the x-axis should be until 50. Okay. And here the range should be 50, from 1 to 50. Again. Failed. What is failed? Okay. Maybe here maybe, yeah, maybe this is the problem. It should be 49. Run. Yes. Sorry, online people. So we'll finish in 1 minute. Again, it takes time because simply we increase the number of the clusters. So it do all of this calculation for all the 50 cluster. Well, we can see here. You see Kata? You can see clearly that you have very steep curve until 5, 6 maybe, and then the curve start to be a bit shallower. And if you increase your cluster to 100 cluster, it will be the same. It doesn't matter. So the number of the clusters, it will be 4, 5, 6 around.
Arbitrary. Where we plot this inflection point.
Why?
It's also visual evaluation that it looks like.
Yeah, it's visual evaluation. Yes, of course. It's again, it's interpretation. It's interpretation, Kata, You are scientists, you interpret it. So actually here it's 5, but when we start to look at the data, we decide to work with 4, not with 5. Because we interpret the data, okay, 5 makes sense, but it will be too much. 4 makes sense, much better. And we use 4. So it's interpretation, yes. It's interpretation. And this is why you, as a scientist, we didn't leave it for the machine to do everything. Right? And then we use this number, which is 4 in our case, and put it in the code, in this code. So number of cluster, we know from the figure it's 4, it's 5, okay? Calculate the key means and start to plot the figure in order to visualize this, these 4 clusters. And we know that our data is very complicated. It's not X and Y. So it's not easy to visualize it in X and Y figure like this. So we visualize it using this figure. So this is the 4 different clusters. So the yellow one, the blue one is a cluster, the green is a cluster, the red is cluster, and the violet is a fourth cluster, just to visualize it. Okay? But now you understand the mathematics and the logic behind this calculation. It's easy, you can copy this code and you can do it in your work, but you need to understand how it's works. Correct? The codes and the data and everything, it should be online, hopefully tonight, and then you can use it to test. Any question from our colleagues online? I don't think our colleagues online is here anymore. Are you still here? No one here. Okay. Anyway, good. So I think just for the master students, we have like a seminar this Thursday, right? We have a seminar from when to when? Matter because I will not be here. Yeah, we should start now. It should from 12 to 2. Yes, but unfortunately I will not be here. So you can just open the room and get the seminar, or the group starts it together and work together. I don't know what's your plan this Thursday, if you are working on the data management plan or you start to plot your data. But try to do either this or that, and then next week we have a lecture Monday, and then we can, before we start the lecture, we have this very brief discussion on the seminar. I think Kata, you will not attend because you will come to this meeting. You will attend to the meeting. Okay, good. So just this is the student who will not attend the meeting. Yeah, good. Great. So this is good. I hope the rest of the students who will not attend the seminar to come to the meeting, because the meeting is important as well. Right? So Vardubar. So thanks all, and see you next Monday, I think. Right? I think it's Monday. Early Monday. 8:15. Don't know why they put this such two early meetings. Okay, Victor and Lynn, thank you very much. I will shut down the meeting now. So see you next Monday.